Alright guys, so one quick thing I wanted to go over. I know I've gotten a hold of a couple of you and have talked to you about time management. So, as teachers, we are noticing that some students are struggling with time management. And one of the things that I think would be a great idea for you is to schedule out a time to do each class. For instance, say you get up at 9 o'clock. You go from 9 o'clock to 10 o'clock. That could be math. From 10 o'clock to 11 o'clock, you could do earth science. From 11 o'clock to 12 o'clock, you could do global. Or you could wait and do it from 1 to 2 or 2 to 3. But make sure it's every single day. Otherwise, you're going to run into the same issue that a lot of people are running into, where they're feeling overwhelmed because they have to make up 6 things of work. So instead of doing that, schedule an hour for your core courses. That's English, math, science, and social studies. You spend an hour a day on each of those, and you'll start to not feel as overwhelmed. And if you do it during the school day, which you should be, you can get a hold of your teachers during their class hours to ask questions. Now that we have that out of the way, we can do notes. Some of you have asked if you could write notes in a notebook. I'm totally good with that. However, taking notes is best for you. You do it. Continuing on, we are looking at sedimentary rocks. So we just finished minerals and igneous rocks. Now we're doing sedimentary. So what is a sedimentary rock? Well, they're formed from accumulation of sediments, organic matter, or chemical precipitates. How they form. So if you remember, minerals make up rocks. Igneous rocks is solidification, cooling and solidification. Now sedimentary, they are formed by sediments that have been weathered, broken down from other rocks. You can see that right here, how they're broken down, they're falling down, and that makes sediments. These weathered sediments are then eroded or transported by water, wind, and moving ice or moving ice. Eventually, the eroded sediments are deposited at a new location, either in water or on land. And right here, you can kind of see these fall down here, and then some fall into the water. And then it starts to build and build and build. After years of this accumulation with a pressure created from the weight above, it compacts the sediments and gets cemented. So those two words are really, really important. Compact and cemented. Sedimentary rocks are formed by compaction and cementation, which you can actually see when you look right here on the reference table in your rock cycle. So this is just an illustration of showing what happens. So you have layers of sediments deposited. You have clay from when it was like deep in the sea, and then the water level dropped, and then you got silt, and then it rose back up again, and then you got clay, and then it dropped significantly to like a beach where you got sand, and then it dropped again back down to silt. And then all of a sudden you start getting all this pressure because more and more gets laid on top. More and more and more. So it's pushing and pushing and pushing and smushing and smushing and smushing. And because it's typically in water or uses water, it compacts and cements. So there are 3 types of sedimentary rock. The first type you have is clastic or fragments. They form from inorganic rock particles and sediments that are pressed and or cemented together. So compaction. This is where they're pressed together by the weight of overlaying rocks. Cementation is where sediments are glued together by natural sediments in the water, like calcite. So water helps to cement this stuff together. And then here's a question. What happens after everything's deposited? Well, what you see is all this loose sediment is deposited, and then it starts to settle in and then gets compacted and pressed on by other stuff on top. And then eventually, because of natural sediments dissolved in water, it cements together. So 3 types of sedimentary rocks that are classic. So we have clastic, and now we're going to look at some classic rocks. So right here you have some grain size. You can definitely see this right here in the top part of page 7. I have highlighted again. Highlighted right here. When you look at grain size, right over here, right there, you're going to see boulders, cobbles, pebbles, and then it's going to go down and you're going to have sand, and then you're going to have silt and clay. It's at this top part right there. So comments. You've got grain size and like comments. That's another one right here. You also have composition, but right now we're going to look at comments. So comments. What you're going to see right here is like rounded pebble. It looks like pebble soup. That rock name is called conglomerate. And then you have this one where it's kind of look more angular, like rectangles, and just it looks like it could hurt you if you stepped on it. That's called breccia. I think it's going to break you. And then you've got sand. Sand comments, it says it's fine to coarse, sand, sandstone, and then you've got this very fine silt, makes siltstone, and then you have clay. This is compacted and may easily split. This is called shale. That one's a little bit different. And how I remember that is shall not be shiny. It'll come in handy later. So our second type is crystalline or chemical crystalline or non-clastic. And this forms when dissolved minerals in water that settle out, which are called precipitates. So all this right here is settling out, and you can see it settling on the bottom. These are all minerals in that water that are just settling out. And then you have formed from minerals left behind when water evaporates, like the salt flats in Utah. Salt water, the water evaporates, you're left with salt. All right, so let's look at a couple that are non-clastic. You've got sedimentary. You've got this sedimentary rock, and it's made up of this mineral. If we look back to our minerals, that is halite. Halite, when you look down here, halite makes rock salt. And then you've got this big chunk of really, really dark white, or not dark, but opaque white. And right here you have almost flat sheets, and that's one where you can scratch. That is gypsum. And gypsum makes up rock gypsum. For some reason I have highlighted, and I shouldn't. And then you have this one last one down here, which is, I want to say, dolostone. That is made of dolomite. We didn't look at that one. So here's some rocks, some of the sedimentary rocks. And then the last but not least, we have crystalline or bioclastic. So up here, here's your classics. Here's your crystalline or non-clastic. And then we have the last two, which is the crystalline or bioclastic. These are fragments of living things that were living, that form from and they form from the accumulation of plants and or animal remains that are transformed and changed into rocks. So this first one you have, it looks kind of like oatmeal-ish. It's bioclastic limestone. It's big shell fragments cemented together by calcite. You can see it's like all smushed. It looks kind of cool. And then you've got this limestone that's crystalline. It looks like if you were to pulverize all of those chunks of shell and then cement them together, that's what it looks like. So this dissolved shell fragments cemented together by calcite. And this last one is bituminous coal. This stuff comes from like Think of it like bogs and stuff like that, because the water just kind of sits there and there's no real movement. When the plants die, they kind of like wilt over into the water and sit there. They don't decompose. So they pile and pile and pile and pile and pile. And eventually they pile enough where you can see it's bituminous coal. How I can tell the difference between the other coals is you can see the layers. Sedimentary layers. They're compacted plant remains. So the formation of coal. Looking at this. So first you have is they layer down, but then the water kind of goes away, and you get this peat. You might have heard of peat moss. That's the start of it. And then you get lignite. This is the next part. And look, there's 50% carbon in peat, 72% in lignite. And the next you have is that bituminous that we were just talking about, or soft coal, and that you can see the layers. That has 85. And then anthracite, this is the stuff that we burn because it's 93% carbon. It's hard coal. And we're going to get to that when we get to metamorphic. You can see how it's shiny and not so shiny right here. And then finally, what I don't have on there is this can get formed if enough heat and pressure get there. You can form a diamond. So this is as time goes on. All right, so real quick, we are going to try and figure out which one is which. So up here, let's first try to look for rock gypsum. So remember, gypsum is kind of like drywall. So look for kind of an opaque white. That's definitely not it. Not opaque enough. No. Oh, right here. I'm going to say 4. Okay, let's look for rock salt. Remember, halite. Semi-translucent, clearish. The only one you're going to find is number 1. Breccia. Breccia is going to break you. It's got those angular bits in it. Like, you step on it, it's going to hurt you. It'll cut your foot up. Number 2. Conglomerate. That one's going to look like pebble pudding. It's just going to look like a whole bunch of pebbles put together. Number 7. Limestone, and in this case, this one is going to be the bioclastic type, which is going to look like a bunch of oatmeal, which you should figure out is number 5. Shall not be shiny. This one I don't like as much because it kind of looks shiny right here. Another way you can figure out shale is in shale you will find fossils, and you can see some fossils right there. It looks like maybe plant or a leaf at one point. So number 8. Sandstone looks like sand in the form of a rock. Number 6. And bituminous coal, that one's going to be just about black. It's going to be like a brownish black. You're left with number 3. Okay, so make sure you do your Kahoot and you submit it. If you have any questions, please get a hold of me during a Zoom meeting. If you can't make a Zoom meeting, you need to get a hold of me. I need to get you guys going on everything. So if you have questions, if you don't understand something, come to me with questions, specific questions. Okay? Have a nice day.